Okay, so in the previous section in chapter 7, we took a look at a special integration technique called integration by parts. So we have now integration by use substitution and integration by parts, which are two like fancier integration techniques that we have at our disposal. And today in section 7-2, we're going to look at trigonometric integrals, and we're going to look at a way for us to evaluate different types of trigonometric integrals. So you guys are going to see some new techniques in this section. You're going to see some techniques that we've already used in this section, and then you'll see some techniques that we've learned that get like modified for certain types of integrals in this section. Okay, so we're going to look at some examples here, the first of which asks us to evaluate the integral. And with number 1, we have the integral of the sine of x quantity cubed, which we are integrating with respect to x. And we've worked through this integral in the past. So what we want to do in this particular case to integrate is we can break sine cubed up into the sine of x times the sine squared of x. And then we can use our Pythagorean identity to rewrite sine squared as 1 minus cosine squared. And then when we rewrite sine squared as 1 minus cosine squared, then that makes this integral a candidate for u substitution. Okay, so we can let u equal the cosine of x, which makes du equal to negative the sine of x dx, and dx is equal to negative du over the sine of x. So this integral here then becomes the sine of x times 1 minus u squared, so we're going to replace cosine with u, and then we're going to replace dx with negative du over the sine of x. So the factors of sine cancel, and this integral here becomes the integral of 1 minus u squared, which we're integrating with respect to u. I'm just going to distribute the factor of negative 1 across both terms, so that's the integral of u squared minus 1, which we're integrating with respect to u. And then we can take the antiderivative of this, so this becomes u cubed over 3 minus u plus c. And then the last thing we have to do is replace u with cosine. So this is the cosine cubed of x over 3 minus the cosine of x plus our constant c. Okay, so that becomes the antiderivative of sine cubed. Okay, with number 2, we're going to take a look at integrating sine squared. So we can't integrate sine squared the way that it's written right now. And if we try using the same technique that we used with example 1, if we rewrite sine squared as 1 minus cosine squared, I can't do u substitution here because if I let u equal cosine, there is no factor of sine that I can cancel whenever I differentiate that equation. Okay, so we're stuck right now. Like we have no technique that we are aware of that allows us to integrate this function. Okay, so we're going to take a look at some stuff that we've learned in the past and how we can use formulas that we've looked at back in trig to help us integrate functions of this type. Okay, so we have double angle formulas. So the one you guys should be aware of, the one that you get used, the one that gets used a lot in trig is the sine of 2x. You should know that that's going to be equal to 2 times the sine of x times the cosine of x. And then when we look at double angle formulas for cosine, there are 3 of them that you have to know. Okay, the first one is the one that you should memorize. So the first double angle formula is going to be cosine squared minus sine squared. And then once you have that first double angle formula for cosine, you can come up with the other two very easily. So if we replace sine squared with 1 minus cosine squared, then that gives you your double angle formula written in terms of cosine only. Okay, so whenever you distribute the negative and combine like terms, that's going to give you 2 cosine squared of x minus 1. Okay, and then you can also write that double angle formula in terms of sine only. So if we replace cosine squared with 1 minus sine squared, again utilizing that Pythagorean identity, when we combine like terms here, we get 1 minus 2 times the sine squared of x. Okay, now what we're going to do for these two equations is we're going to take these two equations here and we're going to isolate the trig function squared. Oops, sorry, this should be cosine of 2x. Okay, so when I isolate my two trig functions squared, I'm going to do the equation in red first. So we get the cosine of 2x equal to 2 cosine squared of x minus 1. So I want to isolate cosine squared. Okay, so to do that, I'm going to add 1 to both sides, which is going to make 2 times the cosine of 2x equal to 1. Sorry, that's going to make 2 times the cosine squared of x. Yikes. So 2 times the cosine squared of x, cosine squared of x, equal to 1 plus the cosine of 2x. And then when I isolate cosine squared, I'm going to multiply both sides by 1/2. So that's going to make cosine squared equal to 1/2 times the quantity, 1 plus the cosine of 2x. Okay, so that's our first equation that we're going to need to know for this section. Okay, I'm going to take the equation in green and for the equation in green, I want to isolate sine squared. Okay, so I'm going to add 2 sine squared to both sides and then subtract the cosine of 2x on both sides. So that's going to make 2 sine squared of x equal to 1 minus the cosine of 2x. And then again, I'm going to multiply both sides by 1/2 or divide both sides by 2. So that gives us the sine squared of x equal to 1/2 times the quantity, 1 minus the cosine of 2x. Okay, and that's the second equation that we're going to need to know for this section. Now, these two equations have a special name in trig. These are what are called our power reducing formulas. So all these power reducing formulas is they're just like a modified equation of the double angle formula for the cosine of 2x. So the first one allows us to rewrite cosine squared. The second one allows us to rewrite sine squared. Now, we'll see this with the last example that we do today. If you want, you can also take this equation here, so the double angle formula for sine, and if we isolate the sine of x times the cosine of x by multiplying both sides by 1/2 or dividing both sides by 2, that's going to be equal to 1/2 the sine of 2x. Okay, so remember this, we'll come back to this formula here at the very end of this lesson. But it's not as important to remember that one as it is the power reducing formulas. You guys are going to use the power reducing formulas a ton in this class. Not only in this section, but whenever we get into polar coordinates and doing calculus with polar curves and finding area between polar curves, that's the C portion of calculus. You guys are going to use those power reducing formulas all the time with that stuff. Okay, so let's go back to this example that we have here, number 2, when we're asked to integrate the sine squared of x. So if I want to integrate sine squared, we said that using the power reducing formula, I can rewrite sine squared as 1/2 times 1 minus the cosine of 2x, which we're integrating with respect to x. Okay, so we're just plugging that formula in the place of sine squared, and when we do that, we now have a function that we're able to integrate. So we can pull 1/2 out front, and then we can go ahead and take the antiderivative of 1 minus the cosine of 2x. So the antiderivative of 1 with respect to x is x, minus the antiderivative of the cosine of 2x with respect to x is 1/2 the sine of 2x. And then we have to make sure we add our constant c to the end. And then the last thing I'm going to do is I'm going to distribute 1/2 across both of those terms. So that becomes x over 2 minus 1/4 times the sine of 2x plus our constant c. Okay, so there we are using our power reducing formula to rewrite the sine squared function and put it into a form where we can integrate. Okay, so we're going to do some more examples evaluating trigonometric integrals. So directions here ask us to evaluate the integral, and for number 1, we are given the cosine of x raised to the 4th power, which we are integrating with respect to x. Now, when we look at this function here, we can rewrite the cosine of x to the 4th power as cosine squared of x quantity squared. And if we rewrite cosine raised to the 4th power as cosine squared quantity squared, then we can use our power reducing formula to replace cosine squared with 1/2 times 1 plus the cosine of 2x. And then we're squaring that and integrating that with respect to x. Okay, so what we have here is a product that we're squaring, so we have to apply that exponent to each of the factors. Okay, so that gives me 1/2 squared, which is 1/4. I'm going to go ahead and pull that out in front of my integral. And then we have 1 plus the cosine of 2x quantity squared. Now, I can't integrate that the way that it's written, so I'm going to go ahead and expand that out. Okay, so if I FOIL that out, 1 plus the cosine of 2x quantity squared, that's going to become 1 plus 2 times the cosine of 2x plus the cosine squared of 2x. Now, we've made some progress because we can integrate those two terms, but we still cannot integrate the cosine squared of 2x. Okay, so I'm going to have to use the power reducing formula to rewrite the cosine squared of 2x. Okay, so this is going to be equal to 1/4 times the integral of 1 plus 2 times the cosine of 2x plus, if we want to rewrite cosine squared of 2x using that power reducing formula, that's going to be 1/2 times 1 plus the cosine of, and then we have to double the argument of that angle. Okay, so the argument is 2x. I have to double that to get the cosine of 4x. Okay, so then I'm going to distribute 1/2 across both of these terms. So this is 1/4 times the integral of, now if you guys don't mind, I'm going to combine two steps in one. So when I multiply 1/2 times 1, that's going to give me 1/2. And then when I add 1 to that, that's going to make 3/2. So 1/2 plus 1 is 3/2, plus 2 times the cosine of 2x. And then I'm going to distribute 1/2 across the cosine of 4x. So that becomes 1/2 the cosine of 4x. And now we have something that we can integrate here. Okay, I can integrate that term by term. So this is going to be 1/4 times the integral of 3/2 is 3/2 x, plus the integral of 2 times the cosine of 2x is going to be the sine of 2x, plus the integral of 1/2 the cosine of 4x is going to be 1/8 the sine of 4x. And then we're going to add the constant c to the end. And then the last thing for me to do is to distribute 1/4 across all of these terms. So 1/4 times 3/2 x is going to be 3/8 x, plus we have 1/4 times the sine of 2x, plus 1/4 times 1/8 is 1/32 times the sine of 4x, and then we're going to add our constant c to the end. Okay, so in this particular case, we had to use the power reducing formula twice. We had to use it in our initial step here. So to rewrite this function here, and then we also had to use it in the other step that I have highlighted. Okay, so down 2 lines further. Okay, I want to see you guys give 2 and 3 a try. So get those 2 questions copied, and then work on those 2. Once you're done, unpause the video and we'll take a look at both of these together. Okay, so when we look at number 2, here we have the product of a composite function and a trig function. This one is a very simple u substitution. So if we let u equal the inner function in the composition sine, then we can take the derivative here. So the derivative of sine is cosine of x dx, which makes dx equal to du over the cosine of x. So we can rewrite this then as the integral of u cubed times cosine, and then we're replacing dx with du over cosine. So this becomes the integral of u cubed du. And then we can integrate that function. That becomes u to the 4th power over 4 plus c. And then the last thing for us to do is to go back and replace u with the sine of x. So this is the sine of x to the 4th power over 4 plus the constant c. Right? So very simple integral for you to evaluate using a u substitution. Oh boy. Well, you guys aren't going to like me for this, but I'm sorry, I copied number 3 down wrong. That was the same problem. So hopefully you're looking at that thinking, I think that was a mistake. So 3 should be the integral of the sine cubed of x times the cosine squared of x. My apologies for that. Okay, so let's take a look at this one. We can't do a u substitution the way that this is written right now. Because if I let u equal sine, then we won't be able to get cosine squared written in terms of u. And I can't let u equal cosine because we won't be able to get sine cubed written in terms of u as well. Okay, So what we actually have to do with this one is we have to do a little bit of algebraic manipulation to this before we can evaluate our integral here. Okay, so what we can do is we can break sine cubed up into the sine of x times the sine squared of x times cosine squared of x. And then what I can do now is I can rewrite sine squared using the Pythagorean identity. Sine squared plus cosine squared is equal to 1. I can rewrite sine squared as 1 minus cosine squared. And once I've done that, now I can simply do a u substitution here. Because if I let u equal cosine, when I differentiate cosine, the derivative of cosine is negative sine of x dx, which is going to make dx equal to negative du over the sine of x. So I'm going to, if I let u equal cosine, I'm going to be able to get this integral written in terms of u and du only, which is what we want with a u substitution. So we have the sine of x times 1 minus u squared. We're going to, again, replace cosine with u, so that's u squared. And then we're going to replace dx with negative du over the sine of x. Okay, so the signs cancel. I'm going to distribute negative u squared across these two terms. Okay, so when I do that, that's going to become the integral of negative u squared plus u to the 4th power, which we're integrating with respect to u, and then we can go ahead and integrate that term by term. So the integral of negative u squared is negative u cubed over 3, plus the integral of u to the 4th power is u to the 5th power over 5, plus the constant c. And then the last thing for us to do here is to replace u with cosine. So this is going to become negative the cosine cubed of x over 3 plus the cosine of x raised to the 5th power over 5 plus the constant c. And my apologies for copying that wrong. Be honest, I'm such a perfectionist, I thought about just stopping the video and like reshooting it again to fix the error, but I'm not going to waste 23 minutes of video time to do that. I'm a little pressed on time. Okay, so we're going to take one quick little note here, and then I'm going to stop this video, and then I'll finish the last two examples in the next video. So something to make note of, it says if you have an odd power of sine or cosine, it can sometimes be a good idea to break it up into an odd power times an even power. Okay, and that's not always true. Like if you look at number 2 here, like we didn't have to break sine cubed up into sine times sine squared. But if we look at what we did with number 3, we were able to take sine cubed and break it up into sine times sine squared, and then replace sine squared with 1 minus cosine squared. So sometimes that's a good idea. If we look at the first example that we did in this lesson, that was another example of us taking sine cubed and breaking it up into sine times sine squared. Okay, so sometimes that's a useful technique for you when evaluating trigonometric integrals. Okay, so we'll stop this video here, and then we'll finish the video off, or finish the lesson off in the next video.